case classes. In this video, we will study about Nyquest plot. Nyquest plot, it is just similar to that of polar plot. In polar plot, the value of omega is varied from 0 till infinity. But in Nyquest plot, it is just an extension to that of a polar plot. Here, the value of omega is varies from minus infinity till infinity. In other words, we can say that this is just the mirror image of Nyquest plot. And in polar plot, we have studied the transfer function of a open loop control system. But in Nyquest plot, we will study about the in closed loop control system, what is the transfer function, and by help of this transfer function, we will check its stability. Let us have in the open loop control system the gain bar, that is g of s is equal to s plus z1 divided by s whole into s plus p1. Suppose this is the transfer function for a open loop control system, and if I put it in a closed loop control system and having the feedback is equal to 1, that is h is equal to 1 is here, then I can get that is c of s by r of s, which is equal to, we know the formula is g of s divided by 1 plus g of s into h of s. Now by putting all these things here, I can get it that s plus z1 divided by s whole into s plus p1 whole divided by 1 plus s plus z1 divided by s whole into s plus p1 into 1. By simplification, we will get here s plus z1 divided by s whole into s plus p1 whole divided by s whole into s plus p1 plus s plus z1 divided by s whole into s plus p1. This one is the equation and the transfer function for a closed loop control system. If I take the denominator part, these things as f of s, suppose f of s is equal to s whole into s plus p1 plus s plus z1 whole divided by s plus p1. If I take this thing as f of s, then in f of s, what is the zero and what is the pole? The zeros of f of s is these things. Now, in f of s, what is the zero term? Zero term is this one, and this one is placed at the pole term of c of s by r of s. That means 0 of f of s is equal to the pole of c of s by r of s. Pole of c of s by r of s, and the pole of f of s, pole of f of s, which is equal to s whole into s plus p1, and this is the same thing is in the g of s part. So the pole of f of s is equal to the pole of g of s. From these two lines, we can get the zeros of f of s is equal to pole of c of s by r of s, which is the transfer function, and the pole of f of s is equal to pole of g of s. That means if we put this thing, that means this one is equal to 1 plus g of s into h of s. We have to find this thing in our mind. That is, no, every time we have to calculate c of s by r of s. We have to calculate only the term 1 plus g of s into h of s. Every time we have to calculate. That means after calculating this part, we can get the zeros of this thing is equal to the pole of c of s by r of s, and the pole of this thing is equal to the pole of g of s. From this point, we can get the pole of c of s by r of s. That means if the poles are straight at the left hand side of the s plane, that means the system is stable. That means from this equation, if the zeros are placed at the LHS of the s plane, then the system is stable, because the 0 of f of s is equal to pole of c of s by r of s. That means we have to calculate every time, that is the 1 plus g of s by h of s. By this equation, we can get the pole and the zero of the transfer function, by which we can got the system is stable or not. The main condition for the stable is that all poles should be reached at the left hand side of the S-plane. The Nyquest stability criteria depend upon principle of argument. Here we have to study in G of S and H of S what is the number of pole and what is the number of zero. Suppose the number of pole is equal to P and the number of zero is equal to 0. In that case, we have to find how many times the number of encirclement takes place. That means we have to find P minus Z term, that is number of encirclement N, which is equal to P minus of Z. This is the most important formula in Nyquest plot. That means N is equal to P minus Z, where P is equal to number of pole and Z is equal to number of 0. And if the G of S and G of S into H of S contains only pole, there is no 0, in that case we can find the encirclement direction is in the opposite direction of that of G of S and H of S. That means if Z is equal to 0, if Z is equal to 0, we can get N is equal to P. Here in that case, the direction of encirclement direction is equal to the opposite direction of S-plane. Opposite direction of S-plane. Similarly, if the G of S and H of S contain only 0, that means there is no Z turn. If pole turn is absent, that means N is equal to only 0. In that case, the direction is always the same direction of the S-plane. The direction of encircle is same direction of S-plane. After getting this, next we will study what is the procedure to draw the Nyquest plot. Now we will study how to plot the Nyquest plot. In Nyquest plot, two main things we have to remember. The first point is, first we have already drawn the polar plot, and the first point in Nyquest plot is that to make its mirror image from minus infinity till 0, and the second point is number of encircles. So we will study all the points one by one. The first point is locate the pole and zero of a transfer function. In the question, the transfer function is given to us. We have to find what is the pole and what is the zero, and how many poles, how many zeros are present. So the first point we can get it easily. The second point is that we have to find the polar plot. We know in polar plot, first we have to put in place of S, we have to put S is equal to j omega. Then we have to find magnitude of G of j omega. Then we have to find its angle, and both the magnitude and angle done, we have to vary the omega value from 0 till infinity, and we have to construct the polar plot. In polar plot, the value of omega is varied from 0 till infinity. This is the main point. From 0 till infinity, the value is varied. And the third point is the new point. The third point is we have to put the mirror image of polar plot. That means in previous we have put 0 till infinity, the value of omega, and here we have to put the value of omega for the extension point, that is from minus infinity till 0. That means it is the full package from minus infinity till infinity. The total plot is plotted. The third point is to find the mirror image, and the fourth point is to draw the infinity radius half cycle. Here in this circle we have to find what is the starting point and what is the ending point. The starting point in this circle is that the mirror image of the polar plot end. The mirror image of the polar plot, where the plot is ended, the mirror image where it was ended, that will be the starting point of the circle. And where the circle will be ended, it will be ended at the point where the point polar plot started. The polar plot starting point will be the ending point of the circle, and the mirror image ending point will be the starting point of the circle. By getting the starting and ending point, we can get the half encircle of the Nyquest plot. By doing all these four terms, we can easily plot the Nyquest plot for a control system. Thank you.